Hey, this is Seth Adjei, an assistant professor in the School of Computing and Analytics. I'm going to be talking about knowledge graphs in this module. We'll try and understand, among other things, what the definition is. We'll also discuss techniques that have been used in the context of education to learn these or create these knowledge graphs, and of course, to also refine them. And then finally, we'll discuss, some of the application areas. We'll talk about some of it briefly at the beginning. We'll look at a specific education-related application as we move on. In the very first video of this module, we'll just focus on just the definition. And by the end of the module, you should be able to define a knowledge graph, and also show examples. Now, if you read Hogan et al. 2021, you'll notice that there are lots of definitions that are available, hundreds of them. He even just focused on just a few. And in those definitions, Hogan says they are contentious for a number of reasons. One, many domains have different definitions for them. To sometimes the way they're defined applies more to the domain than it being very generic. But for our purposes, we just want to look at the key components of a knowledge graph. A knowledge graph is a structured representation of knowledge. Usually you'd find that it has entities and it has relationships among or between the entities. Sometimes it's represented as a graph, and the graph has nodes in them. The nodes represent the entities, and edges, the edges connect the entities to each other, and the edges may be labeled. The nodes may also be labeled. For our purposes, the knowledge graph has knowledge components as the entities, and they're represented as nodes. Note though that knowledge graphs are applied in many different domains. In this very context, I'm just mentioning just a few of them: semantic web, Internet of Things, cybersecurity, and for our purposes, education. So there are many others. We will not have the time to talk about all of the application areas and all the techniques that are used there, but we're just going to be focused on education. And as far as education is concerned, one typical application of knowledge graphs is in the creation and use of prerequisite skill graphs. In a prerequisite skill graph, you have nodes. The nodes represent skills or knowledge components. You have edges. The edges represent pre or post-requisite relationships between the knowledge components. And they can be organized in many different formats. They appear in many different formats. They could be graphical and in many other ways. You would see a few examples in textbooks. So in a textbook, you would usually find the preface where the authors might tell you as the instructor or as the reader of the book, the order in which they want you to read the chapters in there. Some of the chapters could be read together around the same time. Sometimes others could be read, in a format that makes it easier for you to study the material. In other cases, they are also represented as learning trajectories. In other words, they show you the trajectory that you will need to follow to be able to understand the material and get the most out of the material. The next slide shows the simplest prerequisites graph, where in this graph you have two nodes, adding of mixed numbers and subtracting fractions. Basically, the idea is these two nodes are related. The arrow points from one knowledge component to the other, and it is, in this case, pointing from the prerequisite to the postrequisite. In other words, for a student to do well in answering questions relating to subtracting fractions, they need to know and understand or master adding mixed numbers. Many systems have many representations for these. In the assessment system, you will notice that they have a graph that looks like this, where the rectangles represent the nodes, and they point from one skill to the other. They have been colored just to make it easier for you to tell or categorize the skills by grade level. The lower level skills are on the left side. They are in the pinkish red colored boxes, and the higher level or higher order skills should be in the ones that are colored as green. This is just a subset, a small section of the skill graph that the assessment system uses. If you know about Achieve the Core, it's an organization that's actually attached to the Common Core State Standards for mathematics. They have a set of standards which talk about core principles that students should learn in math for every level of education up until they are done with high school. And so the notes here represent the Common Core standards, and you can tell that the arrows point from one standard to the other, showing the order in which they should be taught in a typical classroom so students can learn from it. If you want to read more about each of these, you can go to the website that's linked down there, and you can figure out and understand what each of these standards stands for and how they're used. In other domains, they're also represented as trajectories, learning trajectories. In this very picture, you'll notice that the hexagons, even though they are very difficult to read, represent the knowledge components, and they are connected to other hexagons, indicating the order in which they should be taught diagonally. Some of the groups of hexagons are colored in a particular way. The coloring indicates the grouping of knowledge components, not so much the relationships with them or between or amongst them. So it makes it really interesting and very easy to use. In another learning system like Alex, this is how they represent their knowledge components. The circular nodes represent the knowledge components. The arrows point from one to the other, showing the order in which they should be learned. So generally, clearly, as we have tried to explain to you in this video, a knowledge component is basically a structured representation of knowledge. It has nodes. The nodes connect from one to the other using edges. The edges represent to a very large extent the relationships between them, and the relationship can be defined based on the domain in which it's used. Thank you for watching. I'll see you in the next session.